In the spring of 2013, storms with wind speeds of more than 130 kilometres per hour passed over the country, causing widespread damage, including around 800 pivot and lateral irrigators in the Canterbury area. Since then, a group of engineering students at Canterbury University have been working on a way to prevent such damage occurring again through a project initiated by the Foundation for Arable Research.
The background to this research project was that in the spring of 2013, we had high winds. It's estimated that approximately 800 irrigation equipment fell on the ground. This was significant damage. It's hard to gauge in terms of economic impact, but it was not only the damage to equipment, but the downtime that farmers couldn't be irrigating. Traditionally, FAR is involved very much on the agronomy and the crop husbandry side of things. We did get a great amount of calls from farmers saying what were we going to do about this problem, although it was a bit outside our scope. So Nick Pike, our CEO, had a good think about it and decided to approach the University of Canterbury to see if their engineering students might be able to come up with a solution for this. We sponsored the students to get involved, contributing financially to the project. Once the product was developed, FAR applied for a provisional patent for this product. We are the holders of the intellectual property. We have now entered an agreement commercially with T&L Irrigation. They're a part of the Carfields Group. They jumped on board and were keen to help us develop this product and get it out for wider scale trialing, which will occur this spring. And so hopefully with product validation, and if this product successfully evolves commercially, we will then hopefully collect a royalty that will come back to help sponsor other student projects.
At the first stage of the project, the team looked at various existing solutions, of which we quickly found there were very few. The next step was to gather wind data and also do some computer modelling and wind tunnel testing to work out exactly what was going on to the irrigators in these winds. We found the main issue was the spans shaking themselves to bits, so holding the towers themselves wasn't going to completely fix the problem. We need to hold the spans themselves. We looked at several concepts involving aerofoils and wings, but we did find that the size of these wings would have to be incredibly big to prevent this issue. In the end, we came up with a solution that just involves anchoring the span itself, and the main benefit of the solution was that it can be activated quickly and without too much labour input. Basically, it's an inflatable bag that sits up the top of the span, and when you turn a tap at the centre of the machine, it fills up with water and slowly lowers itself to the ground. And then when it's on the ground, it holds the irrigator steady. The main challenges were in the activation process and also retracting it back to its original position. But we've come up with a few different options there, whether it be counterweight, so it does it automatically, or winch, so you do it by hand. At rest, it's tucked up into a ball in the centre of the span, wrapped up with Velcro straps. These straps then break when you fill it up with water and when it lowers to the ground. And when it's on the ground, it sits full and tethered to the centre of the span. There's a PVC bag, and also we've got a pulley system and counterweight that's used for the retraction. There are several options for filling the bag. We can use an underslung system and have a completely different water supply, or alternatively we can tap into the droppers on the irrigators and fill it that way. Several irrigation schemes won't allow you to take water in the winter, so we'd have to use alternative methods such as water tanks and pumps. The best place to anchor the span is right in the centre, and ideally you'd be anchoring every span, but we're finding several farmers will just be looking at anchoring problem areas such as corner arms. We're marketing the product at a discounted rate at $1,500 a span.
We think the solution is relatively inexpensive compared to other options. We think it's reasonably simple to apply and practical. However, there's still some time to go ahead for the product development itself, whether that's going to be triggered automatically or it's going to be manually deployed. Those are things for the technical group to continue developing. I think the freshness of bringing minds to look at a problem when they are not actually from the industry, an outside view, and especially with young people, it's very refreshing and come up with solutions that we would have never thought of. Initially, FAR thought that probably the solution to the irrigators collapsing was an aerodynamic type of solution. However, the students seemed to come up with a much simpler and obvious choice, which was an anchoring system based on filling it up with water, which is what is readily available in an irrigator.
This program was made with funding from New Zealand On Air.